Thank you very much. Welcome to our presentation on Delphi of this year's AI Safety Camp on small language model training and Evals made easy. So we were a group of 9 different people with different backgrounds, and we had thoughts, and yeah, maybe you had thoughts just as we had as well. Maybe you thought training large language models is a pain. Maybe you thought large language models can be difficult to work with because they're very resource intensive or they're particularly slow. But maybe you've also thought that there's a lot of low-hanging research fruit in small language models. So talking about model sizes of 100,000 to 100 million parameters. Well, and let me tell you, we got you covered. The solution is use Delphi for easy training and evaluation. And let me first guide you through our training part before we get to the evaluation later on. So Delphi's framework provides training for language models, as I mentioned, and it has different features, different things we paid special attention to. So first of all, it's easy to use. You do not use, you just need a few command lines to get the training done. Also, we paid a lot of attention to standardization and reproducibility. So it doesn't matter if you rerun your training or if you do the training on different hardware, it should always be comparable, for example, which is one of the reasons why we took care to get rid of all non-deterministic training features. Further, Delphi also supports all CausalLM model architectures on Hugging Face. For those of you who are not aware of what CausalLM model architectures mean, this means that most or the majority of available language model architectures are compatible, including the recent upcoming architecture of mambas. Furthermore, the Delphi framework saves checkpoints during training and uploads them to Hugging Face. And as you'll see in a second, the ecosystem of Hugging Face is used quite extensively by us, and we hope that a big part of users will also have this take this in favor. So to be more precise, for training, Delphi provides the 3 tools of custom tokenizer training, which is optional. You can also just use the proprietary tokenizer that we provide. And once you have the tokenizer or you choose a tokenizer, you can then run a script on the dataset tokenization, basically representing this the dataset, but in the token version. And finally, you can use that to do the model training. And I just run you through these steps, just similar to a small tutorial. So of course, step 0, we have to install the repo. We clone it with Git. We create a virtual environment. We activate it, install, and also for our convenience, we set an environment variable, a Hugging Face API token, so we do not have to log in every time. So first step is the tokenizer training. So what we need here is a data set and upload it to Hugging Face. You can see here emphasized in the green box. That's our input. We also mention the which feature column we would like to use. And in this case, it's the story column, and of course also the split. And what we have to highlight as well here in pink is where are we going to save the trained tokenizer. Once more, it goes to the specified Hugging Face namespace and is stored there, so we can conveniently use it later after we have run the trained tokenizer script. So after we've trained the tokenizer, we now want to tokenize the dataset. So create out of text, we want to create the tokenized representation. And for this, we again need the dataset from Hugging Face, again highlighted in green, as well as the tokenizer as an input. And as an output, we need to provide where we want to store the tokenized dataset, highlighted here in orange. This you need to do for each split of the dataset, however many splits you have. This example shows us using the train split to create the dataset, the tokenized dataset. So once you've done this, we're basically ready to continue to the training of our model. And to specify our training runs, details, and the architectures, you can see in the red box, we have a JSON config file specifying everything, in which we also specify which tokenized dataset from Hugging Face we use in order to train our model. And in blue, you find highlighted the model that's actually going to be saved to Hugging Face, including all of the checkpoints. And you do this for how many architectures or model sizes you would like to. You run the script, and then you're done with training. Next, you'd like to ask yourself, okay, how do we evaluate the performance of these language models, and maybe also how do they compare? What is my next step here? So what we have to do next is run one more script, and I promise this is going to be the last one before we get to the evaluation. And so what we want to do is we want to create or receive the log probes. What we want to do is we want to take the data set and do the inference, use them as input, push them through the language model, and as an output for each token prediction, we want to save all the probabilities that the model outputs. So for this, we of course need to specify the model highlighted in blue. We need to highlight specify the tokenized dataset, both of which uploaded on Hugging Face should now be obvious. And as an output, we want to store the log probes on Hugging Face once more as a dataset. And once we've done that, we are ready to oh wait, yeah, we have to do, of course, we do this on the validation dataset. Just pay attention to that. And now we're ready to look at the evaluation. So running a notebook, a Jupyter notebook, we created a few widgets. And in these widgets, you could choose a few tokens on which you would like to see the performance of the model. So Delphi does provide a few basic categories, for example, tokens that are like tokens that have a capitalization, but most probably you'll have your specific use case where you want to choose your own set or group of tokens. So this you can do here interactively, for example. And in this case, we chose different names, Tim, Tom, Lily, Sue, and we would like to see the performance. So in the plot below, what you can see is on the y-axis the performance, and on the x-axis different models, and here the different model sizes. So 100K parameter size to 25.6 million parameter size. So yeah, these were the models we trained before, basically. And the blue line represents the median performance for our selected token group. And so we can see a trend here until 3.2 million, it declines, and there at that point it kind of stagnates. Yeah. So whatever you take out, whatever your findings are, depends on your use case, and of course also on the chosen models as well as the tokens. Yeah, maybe you would like to further not only look at this kind of visualization, but have an actual example of an input. So, and here we have a text input. We can choose two different models and see how they perform. So we see model 1 is 100K and model 2 is a 200K. Oops, now this person chose a 400K model, and you can see the inputs here. And what it shows is the different colors show whether one model is better than the other on this specific token, and red obviously shows the opposite, a worse performance. And if you pay attention, it's a bit small now in this slide, you will find highlighted boxes, highlighted tokens, and those represent the tokens that you've chosen previously on the left here, the names. Yeah, so exactly. So this is it. We hope that this will enable researchers that have this hindrance, this hurdle or hesitation to train their own models. They can either train the models that we're currently training, llama and mamba architectures, and once they're ready, use them, or we made it easy for them to train their own models. Yeah, for any questions, please feel free to reach out on the MECinterp Discord channel and check out our GitHub. It's still slightly work in progress, but we're at the very end. Thank you very much.